Now with the wheel, what we have is a wheel with bolts, styrofoam wheel, and we attached a magnet to one set of bolts. And then we allowed this system to rotate on an axis, so it rotates a little better than it does on my fingers. And we wanted to observe the motion of this thing. Now, as you saw, it rotates down and then it oscillates back and forth a little bit. And if we have a good axle, it actually rotates back and forth several times, but with decreasing amplitude. Okay, so there are two phases then that we define for the motion of the wheel. The first phase is where it falls and goes down and eventually comes to rest. That's the end of the phase. Then after that, we've just got the oscillation. We put a thread around the rim of the wheel, and then we ran the other end of the thread over a smart pulley, so that we were able to get many, many data points for the position versus time of this, of the, essentially the rim of the wheel, okay? So we were measuring we were detecting the motion of the rim of the wheel. Then we wanted to do an analysis for the first phase of the motion of the wheel, first phase being from here around to the time it comes to rest before continuing to oscillate. Wanted everybody to get at least 10 good data points for position versus time. Okay. Now what the smart pulley gave us through the vernier interface was the distance that the pulley moved, that the rim of the pulley moved. Now that's identical to the distance that the rim of the wheel moved, the styrofoam wheel. So we very easily get a bunch of distance versus time points. And those points can be sketched in a graph, and the graph can then be divided up into trapezoids. If you have 10 points, you would have 9 trapezoids. By analyzing the trapezoids, and really the only meaningful analysis we can do with distance versus time is slope, which would give us a velocity. Since the displacements are all in the same direction, you can actually get velocities out of this. So the slopes give us velocities, so we can get a velocity versus time graph by looking at the sequence of the slopes and using a little common sense. And then we can take that velocity versus time graph and predict an acceleration versus time graph. And then we can compare with what should happen, which we haven't analyzed yet. And I'm not going to ask you to do too much analysis of that, but there are a couple of little things we want to do. Okay, so we want to get that graph and we want to analyze graphs. Then we look at the oscillations, and I just wanted to see if the oscillations had a constant period. Okay, so that the oscillations would sort of be a simple harmonic motion. And I expect that will be the case, but I don't have the data, you do. So we want to get the peak-to-peak times and see if they're consistent. And if they aren't consistent, then we want to explore maybe why they aren't.